Thanks, Anjali. So I'll pause first before diving in. I think highlighting my career path here, which appears very linear, but is also a function of positions that were available at the time. Where I did my PhD, the University of Arizona, that was the only. I think I was waitlisted maybe at another institution, but that was actually the one that I was accepted at. It happened to be my first choice, so that was great. But that's kind of how the chips fell. My postdoc, where I did at the University of Exeter, was actually a function of a coffee chat actually at a conference. So David Singh, who was my postdoc advisor, I literally ran into him at a conference. I was like looking for a building, and I literally ran into him. But as it turns out, he did his PhD at U of A. We had some connections, and at the tail end of my PhD, I was doing work that was related to matching general circulation models, which is my area of expertise, to observations. And so as it happened at the time, David was looking for a postdoc that did that very thing. So, because I had made that prior connection, actually, my first year of graduate school, it made it even, I imagine, an attractive candidate for when I applied. And so that really, opened up the door for me to, do that postdoc, but also then get the position here.
Give me 1 second.
Sure. Yeah. No worries. Oh, no worries. So I guess while Anjali's doing that, I'll just dive in. Oh, I guess I'll also note another calling card here. You might notice that my PhD was actually in planetary sciences and not in astrophysics. And so as I think multiple people have highlighted, exoplanets is quite an interdisciplinary field. And so I like to, really emphasize the cross-disciplinarity of exoplanets and how a lot of these communities can and should be working together. I actually at JPL work in an area that's more centered on astrophysics, but a lot of the other work that I do, which you can talk to me about later, is related to planetary science as well. All right, so now diving into the decadal survey. It's all right. So thanks, Ellen. While Ellen's doing that, so it's always you've heard the term decadal survey thrown out a bunch now. And so I thought I'd start with just a definition of what is a decadal survey. I mean, the name sort of suggests what it is, but I wanted to look up a NASA definition, and that's what this first slide will show. So I pulled up a definition from the, okay. Oh, no, that's not me. Yeah.
You want to hit the forward.
I was hitting back. Okay,
So
got it.
go.
All right. Thank you.
more.
Sorry, I was hitting the wrong
Go
button.
one.
All right. Okay, what is the decadal survey? All right, this is my slide. So the biological and physical sciences had a nice little webpage that gave a really nice, what I thought, definition of what a decadal survey is. So I'll just read it. Decadal surveys are community-driven, bottom-up studies. So I bolded this myself, produced by the National Academy of Sciences, Engineering, and Medicine. They include medicine now, NASM. So I'll just call when I say national, I'll just use national academies for short. That aim to formulate a community consensus about the most compelling science questions for the decade or more. I added ahead. Decadal surveys play a vital role in helping NASA and other organizations like NSF define and align research to uniquely advance scientific knowledge, meet human and robotic exploration mission needs, and benefit humanity. So I thought that was a nice summary of what it is that decadals do. And so in the case of sort of more relevant to NASA. So NASA's SMD, which Hannah just defined, engages the science community in identifying and prioritizing leading scientific questions and the observations required to answer them. Through the National Research Council, which is an arm of the National Academies, it really helps the operating side of things and the programmatic development. And so what is it that the NRC does? So they conduct studies like the decadal that provide this community consensus. So there are actually other reports out there that aren't decadals, but they are community consensus documents, things like the Exoplanet Science Strategy Report or the Astrobiology Science Strategy Report, some of you may be familiar with. And so those were somewhat off-nominal, opportunities to have the community weigh in on what it is that, the funding institutions at large should be doing in those areas. And so NASA and its partners, places like NSF and so on, once a decade, look 10 or more years into the future in these different science areas and in many cases make recommendations for missions that would accomplish that science, that would make those observations. So what are the decadals most relevant to NASA specifically? So Hannah showed a nice little chart that had the different bubbles of the different areas of NASA. And so these are actually the decadals that are most relevant to those bubbles. So first, you're probably most familiar with the Astronomy and Astrophysics Decadal Survey, which is primarily what I'll be talking about today and what I participated in. So it'll be a very astrophysics kind of focused Astro 2020 perspective. But then there are also other decadals, the Planetary Science and Astrobiology. You can read their long titles here. There's one relevant to Earth Science, which is actually, I think, newer in the decadal process. They've only had a few decadals, one or two. And they're actually in the midst of spinning up their mid-decadal right now. The Biological and Physical Sciences decadal came out very recently in 2023. And the heliophysics one, you can see, is actually quite a decade old because the heliophysics, the newest decadal, is coming out very, very soon. So we're actually paying close attention to that and whatever recommendations come out of that community consensus report. All right, so these are, so I think I said already, I'll be kind of focusing more on the astrophysics perspective, and some of these are slides actually from the astrophysics decadal itself. So I won't, belabor a lot of these points I raised already, but if only to show, this is what the National Academies is presenting as what their approach was. So working with, I think, as Hannah already mentioned, NASA, NSF, DOE, that this document provides budget guidance. What should they be prioritizing in terms of their investments and their science and their technology and so on. There's a lot of language about, ambitious, aspirational, inspirational. These reports, the science and technology that goes into them should be really be ambitious and exciting for the next decade. We should want to do it. So, those adjectives really fold in. But the plan also needs to be realistic, responsible, achievable, and sustainable. So one facet of this that I won't talk too much about, you could ask me later, and other folks in the room will know a lot more about it than I will. But there's a lot of one major constraint for doing the science or achieving the technology you want to develop is cost. So all of these mission concepts that come in as inputs, and I'll show it, I think, in the next slide. One exercise that takes place during this process is that they actually get costed. So external folks will come in and evaluate what's the cost feasibility of each of these mission concepts, I should say. And so that's a factor that, as I'll show in the next slide or two, comes into the consideration of what sorts of recommendations come out of a decadal. So I think I've summarized all of those things. Present a strategy with details of implementation. So it's not just about what it is you want to do, but how you want to do it. And so that's what the decadals are charged with accomplishing. All right, so here is the Astro 2020 process. So I'll say, again, given each of the decadals have their own processes, their own panel infrastructure. So I have some familiarity about the planetary science one, not as much about the other three that I mentioned. So if you want to ask about that or, come talk to me later. But this is just, again, very astro-focused. And so it starts out really from the community. The idea is this is a community consensus document. We should be hearing from the community. And so there are white papers that folks write, and I'll talk about that in a couple of slides, both focused on science, but also activities, projects, and the state of the profession, this APC acronym here. And so those papers are written by members of the community, ideally, groups of folks from the community to really suggest consensus. They want to show that a lot of people agree with whatever it is that the white paper is writing. And so all of those inputs then feed into these various panels. And so there are science panels that are focusing strictly on identifying the compelling science questions for the next decade in different subject areas. I'll talk about in a few slides. There are program panels that follow from that, taking the science input, but looking more specifically to mission concepts, but infusing the science along their kind of findings, not recommendations. And then there's finally this new state of the profession and societal impacts panel, which I think got raised earlier today. And so this was actually a new facet of the National Academies, the Astro 2020 decadal, and I think I hope will, infuse itself into other decadal processes. And finally, so all of those inputs, all of the recommendations, the white papers, the findings that the panels provide, all feed into the steering committee. And so they're really the governing body of this whole thing that finally assimilate all of that information to make actual capital R recommendations. So all of the front matter, if you've ever looked from through the Astro 2020 decadal, all the capital R recommendations were designed by the steering committee. And they make suggestions again for this prioritized investment strategy given budget guidelines. All right, so I'll just, these are just a couple of slides highlighting again the results from that decadal, which came out a few years ago. And so this was shown in this kind of layered structure here, because it's really about building the foundations from grants and laboratory measurements, other things, other guiding principles about having a balanced portfolio and so on. And that really at the ground floor enables all of the really exciting science we want to do. I won't belabor this point too much, but you can ask me about it later. But I just wanted to highlight the ones that are most relevant to this workshop this week. So at the very top, you can see there are different science areas that are highlighted, and then the priority areas that have been identified within each of those science areas. So I'll just skip ahead here. So the science theme I'd say most relevant to folks in this room is worlds and suns in context. And so the idea would be to characterize systems that are that may be wildly different than the one that within which Earth resides. And so the theme encapsulates a bunch of different scientific areas, a bunch of different telescopes, things like using observations from JWST, from ALMA, and so on. And so that's kind of the broad worlds and suns, looking at planets and the stars that they orbit. But the priority area within worlds and suns is pathways to habitable worlds, and some of this might be familiar to you. And so the Decadal identified that that's really our exciting area that we should be prioritizing for the next decade. And then this summary slide here just lists the ways in which that we could enact or implement that pathway to characterizing habitable worlds. And so there's ground-based ELTs, a large space-based IR optical UV telescope, X-ray observations, laboratory theoretical studies. And so some of this may seem familiar to you because this is really what formed the basis and the foundation for developing the Habitable Worlds Observatory, or HWO. All right, so I gave you all of the information about what the Decadal is, and so but I wanted to give you some insight as to how you can participate in the Decadal process. And so of course I'll speak generally from my perspective, but hopefully offer some lessons in general at the end of the talk. So I'll harken back to this graphic here and just highlight the different activities that I participated in relative to this ASTRA 2020 process as a whole. And so I'll talk about this in a couple of slides, but I'll just say that I both participated at the kind of community level, not just through writing science papers, but also participating in a large mission Decadal concept, which I'll talk about in just a second. And then I think that really opened the door for me to participate then as part of a science panel related to exoplanets. So I'll talk about that as well. All right, so this is kind of the first part. So I was able to participate as part of a large mission concept study. So every decadal, NASA initiates large mission concepts to be studied as candidates for the decadal. And so this was true for the ASTRA 2020 decadal as well. And so Hannah's already talked about these program analysis groups, and so they're actually the organizations that solicit community input, solicit these concepts, and they unanimously endorse whatever it is those concepts should be. And so for each of the 4 concepts, NASA appoints then these science and technology definition teams, or STDTs, yet another acronym. And so they're charged with, for each of those mission concepts, developing science cases, flowing those science cases to your mission requirements, how things get designed. They vet technology that would be relevant for that particular mission concept, and then direct trades of science versus cost capability, because again, it's about what science you want to do, but within kind of some pre-appointed cost cap. So this is just a flashback, actually. This is a slide that Paul Hertz presented, I think, back in 2015 or 2016, that outlined those 4 mission concepts I was just talking about. For those in the know, they may look very familiar to you because they were the large mission decadal reports that came out. The Far Infrared Surveyor, the Habitable Exoplanet Imaging Mission, which some of you may know as HABEX, the Large UV Optical IR Surveyor, or LUVOIR, and then finally the X-ray Surveyor, which was eventually called LYNX. So really, all of this groundwork was laid back in 2015. This is the large mission concepts we should be developing, and they stood up teams to do it. So I got to participate in the Far Infrared Surveyor, which evolved to be called the Origin Space Telescope once it incorporated some exoplanet science. It was really focused more on extragalactic science at the time, some cosmology as well. And so when they introduced the idea of doing transit spectroscopy with this MISC-T instrument, the mid-infrared spectrometer, that really warranted a broader name, and thus Origins, I think, was born right around that time. So this is just a picture of the report, a picture from one of the major science themes we outlined here in our executive summary. But I was able to serve as an STD team member, so I was appointed by NASA to be on this team to help co-lead the science working group for exoplanets and define the science case. And so the major exoplanet science case for Origin was related to mid-infrared characterization of terrestrial exoplanets. Think TRAPPIST-1, that kind of system, and what sorts of biosignature gases could we identify in the mid-infrared given these key characteristics of the telescope. And so I just provided an example. This is all in our report. So at the time, JWST hadn't launched. And so our kind of, sticking point was, okay, how does this measure up to JWST? What will JWST do? Or what won't JWST do that Origins will? And so this was a figure kind of illustrating that. For example, here are all the molecules that JWST will identify, but, it won't go this far out. And so we'll be able to, extend out to 20 microns and detect all additional absorption features of these biologically relevant molecules. So this was the sort of figure that, you really think persuasively about, okay, how do I really convince, this National Academies, these panels, that this is an exciting mission that they should consider for the next decade. All right, so that was kind of part one, and then part two, kind of related to that, was I also wrote community science white papers, and I know I've mentioned the word white papers a couple of times. So the numbers here are just on the left showing how many white papers were received. So over 500 contributed by 4,500 authors from the astronomical community. And so what is a white paper in this case? So you'll see here on the right, I've just screenshot, this was the call for community white papers. So that was made, back in 2019, and it listed, what white papers should outline. So they're really persuasive documents. If you have a particular area that you feel very passionate about that you think should be considered for the decadal, that's really what this white paper should entail. So for example, I was involved in a white paper that really argued for the importance of laboratory measurements for exoplanet atmospheres. We only know so much about these molecules and where they absorb at given different wavelengths, given temperatures and pressures, and we need more of those. For example, there's a lot of laboratory work, not just that. But it was a whole paper about, what sort of laboratory measurements are required to advance the field. And so you can either serve as a co-author or a co-signer. And co-signer is important because if you get, hundreds of names, it's like, okay, well, clearly people in the community care about this. And so a lot of the process was about folks initiating white papers and then advertising them, saying, hey, I wrote this white paper about this thing I feel, I think a lot of you will feel passionate about. Please, co-sign. Here's Google, Google sign up link or whatever, and we'll collate your name. And you'll see here the white papers, define scientific context and the importance of those opportunities, number 2. But these science white papers really focus on science. There were other papers that were written that are more, things like the large mission concepts. Those were really specific to missions, specifically, in particular, whereas these were really centered on science and the science inputs that need to be considered for this next decade. And so I think I already said, I contributed to white papers related to my own research in exoplanet atmospheres, but also related to the origin study. We wrote a lot of papers about that as well. And I should say every white paper, all 500 whatever of those were assigned and read to, by one or more of those decadal panels, which I can attest to because I served on a science panel and I read some of them. So further on in the process, the National Academy solicited a call for nominations for these survey committees and panels, the ones that I showed in that flowchart earlier. And so I was nominated, and then I was selected for the science panel for exoplanets, astrobiology, and the solar system. So a lot of science in there, but it really, I think, begat a really cross-disciplinary group of folks that were looking at white papers and identifying compelling science for the next decade. And so using not only the community white papers, those 2 reports I was mentioning earlier, but other input from the community. We actually had folks come and talk to us and give talks on, the future of radial velocity technology in science, the future of the ELTs, for example. And so we used all of that information to then identify what are these 4 key science questions that we deemed the most compelling for the next decade. And those are what's outlined here. It's in the front matter of the decadal as well. We were also tasked with identifying a discovery area, what it is that we should really be pushing towards scientifically. And so you can see the search for life on exoplanets was what we identified, which if you remember, rewind your brain from a couple slides ago, really, I think, served as critical input for what came out of, the final recommendations for the decadal. I'll just mention, so I think briefly, the committees up there, you can find this online, some of whom actually will be at the meeting this week. I think Courtney Dressing will be here. There may be other folks too, but I just know Courtney's talking. But so if you want to talk to her about her participation in the decadal, please do. All right, so I think this is actually my last slide, yeah. So I kind of, obviously spoke of my own experience because that's what I've got. But I wanted to speak generally about, how does this connect to how all of you can participate in the decadal? I think, writing white papers, you can really do at any stage. I don't think that there's really anything precluding you from, if you feel strongly about a particular topic that you think should be infused in the next decadal or even the mid-decadal, write it. Rally your collaborators, your colleagues to co-sign, maybe co-author. And it's a good opportunity also to just build connections with different folks in the field. I think where possible, get involved in mission studies. And so, applying to be an STD member, I don't think there were any particular restrictions on applying. There's nothing to be said about just trying it out and seeing what happens. From my perspective, I actually didn't start out as an STD member. I actually was a working group member for one of the exoplanets working group that I eventually co-led. And so, through the increased work that I did for that group, that led to my eventual appointment as an STD member. Apply to be part of a panel. Again, I don't think there's any particular restrictions on, nominating or self-nominating. I think there's some level of, demonstrating your interest. I don't think there's any harm in applying if you're eligible. Some of these may be more pie in the sky, but participating just generally in science and technology research. If there's anything related to these future decadals that's of interest to you, get involved, communicate, conduct research, communicate those results via papers, conferences, talks. Networking all folds in here because all of it is built from the community. And just relatedly, pay attention to the advances in the science and technology around you. I mean, some of those things may very well become the tenets that comprise the future, set the foundation for the next decadal. And in fact, there are already conversations happening because we are, midway through our decade. And so there are already conversations, I think, spinning up about the mid-decadal report and studies and what that might look like. So, I think just, keep your ear on the ground, talk to folks. Continue doing research and learning about what it is that people are excited about, and seeing where you can potentially hitch your wagon onto those particularly exciting areas. So happy to take questions or talk to you folks after during the break. Thanks.